A very good morning to everyone. I am Dr. Bushra Fatima from Jain Narayan College of Technology, Bhopal. Today I am presenting on a topic PN junction diode. Now, when a slab of intrinsic semiconductor material is doped with travelling impurity at one end while the other end of the slab is doped with pentavalent impurity, then a PN junction diode is formed. This is unbiased PN junction diode. When the junction is formed, the flow of electron starts across the junction due to concentration gradient. As the density of electron is more or n side as compared to that of the p side, the electrons and holes recombine across the junction. As a result, the ions are uncovered on both p and n side in a small region around the junction. On n side, positive ions are uncovered, while on p side, negative ions are uncovered, due to which an electric field is produced at the junction, which is directed from N region towards the P region. This field is called the barrier field. Due to this electric field, the electrons of N regions move in the direction opposite to that of the electric field, that is away from the junction, while the holes of the P regions move in the direction of the electric field. As a consequence, the diffusion of charge carrier at the junction stops. This layer is called the depletion layer. The width of this layer is of the order of 0.5 micrometer. It is clear that due to this barrier field at the junction, some energy is required to transfer electron from N region to P region. This energy required is called the barrier energy, and the potential needed corresponding to it is called barrier potential. Now this is PN junction diode in a forward bias condition. When the PN junction is connected to a circuit such that its P side is connected to the positive terminal of the battery and the N side is connected to the negative of the battery, then the diode is said to be under forward bias condition. The negative per terminal, or we can say that the negative potential at the end side forces the electron to cross the junction. Initially, when the value of applied potential is less than the potential barrier, no current flow across the junction. As the potential applied becomes greater than the potential barrier, electrons start to cross the junction. Further increase in applied potential forces more electron to cross the junction and the current in the circuit increases rapidly. Now, this is the PN junction diode in the reverse bias condition. When the PN junction diode is connected in a circuit such that its P side is connected to the negative terminal of the battery and the N side is connected to the positive terminal of the battery, then the diode is said to have in a reverse bias condition. The positive potential at the N side makes the electron to move away from the junction. Similarly, holes also move away from the junction. As a consequence, majority charge carrier do not contribute to the current in the circuit, but the minority electrons from P side and the minority holes from N side moves towards the junction and the small currents flow across the junction. Now, this is the VI characteristics of the PN junction diode. Thank you all for your attention.